Hello, welcome to section 6.5 about modeling with exponential functions. So this kind of brings together all of the stuff we did in section 6.1, section 6.2, 6.3, and 6.4, but now applying it to real life situations where we're going to have some kind of description of a real life situation, sort of like this one, and try to figure out what kind of function can model that and get a formula for that function. So just a quick review. This version of an exponential function was the first one we looked at in 6.1. And then we looked at this version in 6.2. And then all of these other ones were what 6.3 was about. So if you don't understand where these come from or the basics of how to use them, you might want to go back and review your notes from those or look at those videos again in case you missed them. But basically, let's just do a quick overview of them. So if you have, all of these have something in common. They're all written as an A, where A is just a number times some stuff. And then the exponent is always the variable, right? So that's what makes all of these exponential functions, is the fact that the exponent is the variable. What's different about them is the different ways you can write the base. So either you have just the base to the power t. That means every time t goes up by 1, you end up multiplying the result by a factor of b. That's the basic kind of them, of way of looking at it. Or if you talk about a percentage growth rate, r, that means every time t increases by 1, the output, the result of the function, increases or decreases by r as a percent. But in the formula, you write r as a decimal. So for example, if something's increasing by 10%, you write 1 plus 0.10 for 10% increase to the power t, or 1.1 to the power t. Makes it increase by 10%. And we talked about doubling times in 6.3 and half-lives. With this one, every time the input t increases by d, whatever that is, that's going to make this fraction go up by 1, and the whole result gets multiplied by 2. And same deal with half-life. With the last one here, when you plug in t equals t0, that's going to make the exponent be 0, which makes the whole result just become a times b to the power 0, which is just 1. So you just get f of t0 equals a. So that's my quick overview. If that was too fast, then you might want to go back and check out your notes again for this stuff yourself. Or you might, if you're having trouble with some of these, you might be able to just roll with it and get through these notes okay without reviewing that. It shouldn't be too big of a deal. So let's start with this first example. The goal is to find a formula for n equals f of t, where t is the number of years after the league was formed. So the input is the number of years after it was formed, and it says the youth soccer league initially, that means when it was formed, has 68 members and grows exponentially. And we also know after 2 years. So initially, that is usually going to mean t equals 0. And then after 2 years, that means we're talking about t equals 2. So an important thing about this is that the initial value is always going to be a. Whenever, with any of these, when you plug in t equals 0, you're going to get a as the result. However, with this one, it's a little different. This one starts at a when t is t0. But that's the only one that's different here. So in any case, we've got a equals 68. So the formula is going to be something like f of t equals 68 times b to the power t. But we don't know what the b is here. So we got to figure that out. And the way you can figure that out is using what they tell you about here, is that if it says after 2 years, that means when t is 2, the league grows to 96 members. So this is saying that f of 2 is 96. And there's there's two ways we can write f of 2 is what that's saying. You could write f of 2 using the formula that we have, 68 times b to the power 2. You could also write it as 96 is what this is saying. So this gives you an equation that we can use to find b. So we're not really we could say this is the answer here. Like, we have the formula, but it's not really a complete formula unless you know what the b is. So we have to use this formula here. To find b and have a complete formula. Okay, so let's solve this equation. So if you have 68 times b squared equals 96, you want to get b by itself. If you have multiplication by 68 here, you can divide both sides by 68 to cancel that out. And 68 divided by 96 is, wait, other way around, sorry, 96 divided by 68. Let me make this smaller so you can see it. Is 1.4117 or 1.4118. And I always recommend including more decimal places than you really need at this point, and don't round off until the end. So now to cancel out the fact that it's b squared, we can do a square root on both sides. Remember, you always want to include a plus or minus when you're doing a square root. And so here we're going to compute that. It'll be 1.1881. Right. Let's call it 1.1. There's a 7 after that 1, so I should round this up to 2 there. Okay, so that is b. We can write the formula as f of t equals 68 times 1.1882 to the power t. And you notice I'm only using the positive one here, because one of the things about exponential functions is you never want to have a negative base. The reason for that is that if you do have a negative base, then weird things can come out. Like, if you have a negative number to a power and the power is like 1/2, then that means you're doing a square root of a negative number, and that's not allowed. So for all these problems, just use the positive square root to get the value of b, because negative bases in an exponent are not allowed. So anyways, that's the formula for the function. If you want to check it, it's not a bad idea. You could just plug in t equals 0 and f of 0 should be 68, because that's what it was initially. And that's just going to give you 68 times 1, so you just get 68. And if you want to do f of 2, that's going to be 68 times 1.1882 to the power 2. That's going to come out to be 96. So that works. All right, let's look at example 2 next. We want to find a formula for the exponential function whose graph is shown. So if it's given that it's an exponential function, it means it's going to be something like f of x equals a times b to the x. And I'm just using x instead of t because I guess I have a graph here where it's sort of normal to call this the x-axis. But if you want to call this the t-axis, that's okay too. Either way is fine. But I'm just using this one because this is kind of the simplest version. I mean, you really could solve this equation with any of these with any of these versions of an exponential function and find a function in any one of these forms. It might just be a couple more steps. Because really any exponential function can be written in any of these forms. But that's just not usually the way we do it. It takes a few extra steps sometimes. So anyways, these are the points we know about. We have that the x coordinate is 0, so that means if x is 0, you'll plug that into the formula to get y, and the y should come out to be 120. And in this case, anything to the power 0 is 1, so this just gives you a times 1 equals 120, so that's your value of a. So yeah, the value of a is basically always going to be the same thing as the y-intercept. Whoops. It's the same thing as the initial value. Now, what about this other point? We have that if x is 7, so I'm going to plug that 7 in place of the x, and now I know that the a is 120, so I might as well write it that way, but then we're going to do b to the power x, but using 7 for x. That result should be the y-coordinate, which is 200 here. So, just like the last problem, this gives you an equation that has b in it. Using these values gives you an equation that has the only variable as b in it. And that's an equation that you can solve by using other methods we've done back in chapter 4 and such to find that b. And once you know the a and the b, you have a complete formula. So I'm going to solve this by dividing both sides by 120 to cancel out that multiplication. And 200 divided by 120, I think that's going to be 1.667. Let me check. Yeah. Okay, so you got a bunch of 6's there, and then round one up to a 7. Now, to find b, you can take the 7th root. The 7th root will always cancel out with the 7th power. And you're going to get b. But another way to do this, if you need to do that on your calculator, is of course, instead of writing this as the 7th root, it's the same thing as if you raise it to the power 1/7. That's what the exponent 1/7 means, is it means a 1/7 root. And you can see that if you multiply those, it will cancel out. So then you can use a calculator to estimate this. 1.666667 to the power 1/7. And on your calculator, instead of the 2 asterisks, which my calculator uses for exponents, you use the caret symbol, the up arrow thing, of course. So anyways, that's going to be 1.0757 is the value of b. So that now gives you a complete formula. The formula is f of x equals 120 times 1.0757 to the power x. And that's the answer to the question. I also want to notice something about this, is that if this is greater than 1, that means that your function is growing, which this one is. That 1.0757 is greater than 1. Because every time x goes up by 1, if you're multiplying by this number that's bigger than 1, it's going to go up. And the amount that it's going up is how much over 1 this is. So you could also write this in the form 120 times 1 plus 0.0757 to the power x. And that is like the value of r. That 0.0757, if you write that as a percentage, it's 7.57%. So that's the growth rate of this. So we could say that f of x increases by that much, 7.57%, when x increases by 1. Okay, so just a quick review of that stuff there. All right, I'll do the next couple of examples in another video. So now's a good time to take a little break, have a drink of water. If you need to go back and review some of the older videos, now's a fine time as well. And I'll see you in the next video.